If you're a data scientist or simply getting into data science, there is a high chance that you're using Pandas for your daily analytics tasks. Even though Pandas provides a lot of benefits, it might not be the right choice for dealing with large datasets. I mean gigabytes of data. In this tutorial, I'll be comparing Pandas with another library called Polars. You can pause this video and download the notebook from the description below so that you can follow along. Before getting into the benchmarking analysis, there are a couple of libraries that we need to import. So what I've done is to install the two main libraries, install Pandas and Polars, and also we'll be using Seaborn for visualization purpose. I use this row to ignore the warning sometimes that we can have when running the notebook. After installing the libraries, now we import the necessary libraries. Pandas, Vex is not part of the process. So we import Pandas, Polars, the time, and Seaborn. And after we have imported those libraries, now we can create the benchmark datasets. So I'm using a dataset, and the original one is this original datasets. And to make the datasets bigger, I am repeating each row 100,000 times. What I do now is to store that benchmarking dataset in the same folder, the same data folder. So let's check the shape of this original data. So the shape of the original data is 768. So if I repeat each row 100,000 times, we're going to have 76 million plus rows. So this is something that I've already computed here. So the original data size is 24 kilobytes, and the experimentation data is 1.31 gigabytes. So this is the difference between the original one and the benchmark data set. So now that we have all those information, now we start with the data loading. So we're going to perform the benchmarking analysis in 4 and 5 main tasks: the data loading, data offloading, and so on to data aggregation. We provide the link to the data that we are interested in, which is the benchmarking data set. And since we are in the loading phase, I use a dictionary called loading time, which is going to store the execution time of each library for the data loading. And to do that, this is the helper function used to perform the data loading, and it takes the name of the library and the path to the benchmarking data. We have two main cases. The first case is we're using Pandas, and the second case is using Polars. Pandas is straightforward. We use Pandas read CSV, and between use the starting time and the end time of execution when reading the data sets. And we do the same for Polars. So Polars also has this read CSV function. It's exactly the same for Pandas. And now we store the name of the library and the end time here, which is the final execution time. For the visualization purpose, we have this plot time helper function, which is going to take the benchmarking time, which is a dictionary, and the plotting title. So after we have all this information, now we can proceed with the experimentation. So for Pandas, I use the data loading function, give the name of the library, which is Pandas in the string format, and also the benchmarking data path that I have here. This is the benchmarking data path. And now we execute both Pandas and Polars and plot the loading time here. This is what I was referring when I meant the plot title. The plot title here is loading time. So in loading time, you can see that Polars is much better than Pandas. The execution time is 10.19 seconds and Pandas is 28.51 seconds. So for this first experimentation, Polars seems to be better than Pandas. Let's move forward and see if things are going to change over time. The second analysis is the data offloading. The data offloading is about transposing the original data into a different data format. So what we're doing here is to create a NumPy array from the original data frame. And this is the helper function that is used to perform the data offloading. And we have the name of the library and the corresponding data frame. So both Pandas and Polars have the same function, which is to numpy function. This to numpy is going to convert the data frame into a numpy array. Here is the offloading time of pandas and offloading time of polars. After executing this one, we have the offloading time of pandas seems to be pretty much the same, even though polars remains at the top of the competition because the execution time is lower, slightly lower than pandas execution. Let's move on to the third, which is data grouping. So what we're doing here is to get the outcome values from the data sets and group by age and take the mean value. Here for polars, doing exactly the same thing, but there is a slight change here. We're using another function called .agg, which is going to perform the aggregation, and here we specify the column that we are interested in, which is the age column, and we finally take the mean. After using this helper function, we can apply that function to both pandas and polars. And guess what? The aggregation time is way better for polars than pandas. We have 0.22 for polars, and for pandas we are 1.15. For now, polars seems to be ahead of the competition, so we never know if pandas is going to change things in the next steps. So let's move on with data sorting. Data sorting we have the helper function for sorting the data. So we are sorting based on the pregnancies column here. So with pandas, it's very simple. Use the data frame.sort values by specifying the column which is a pregnancies, and with polars we are simply using the sort function which also sorts based on the pregnancy column. And after execution we have the sorting time for polars, which is 2.19, and for pandas it's 6, almost 6.5. Maybe there's no chance for pandas anymore to make a change in this part, because in the first task polars won, and still pandas is not making any change. And let's see, this is the final step, which is the data filtering. In data filtering we are filtering, like providing the name of a column we're interested in, the value of that column, and then we make the filtering. So using pandas, we use pandas data frame. Actually, this is a data frame that we are providing. Data frame here. Yeah, exactly. So we use data frame, the name of the column, sort based on the value of that column. And here in the library polars, we're using polars, we use the filter function and use polar library.call, specifying the name of the column we're interested in and the value. Similarly, we are doing the filter based on the blood pressure, which is 74 value. So we're taking all the values, blood pressure higher than 74. So as you can see, we have for this final step, which is data aggregation, polars made it again, like 0.24 against 1.16. Polars is the ultimate winner of this comparative analysis. If you are using large data sets to perform your analysis, maybe it might be worth using polars instead of pandas. So if you like this video, give it a thumbs up, and also share, comment, subscribe, and let me know if there are new topics that you want me to cover in my next videos. And thank you for watching. See you next time. Bye bye.